Well, hello everyone. My name's Eric Chappell, Community Evangelist for InfraWorks 360, and I want to welcome you all to today's webcast, Flood Simulation using Project Boulder for InfraWorks 360. With me today are Matt Anderson and Reinaldo Garcia, and you're going to get a chance to hear from both of them about how they are involved with Project Boulder. And we'll get to that in just a few minutes. Before we do, I wanted to talk a little bit about our webcast series and about our community. If you're new to this series, we do this twice a month, first and third Wednesdays of the month. So far we've been able to keep on that track since about April. And our goals are we want to inform everyone about InfraWorks 360 from the perspective of the product team. So Matt, many of you know, is on our product team and deals with product development every single day. So we want to give you that perspective when we talk about InfraWorks 360. We also want to give you a chance to ask questions and provide feedback so that we know that we're on the right track and you can give us some ideas on some of the things that we're talking about. And just generally speaking, we want to bring InfraWorks 360 users closer to the folks who make the software. Some other webcast topics we're thinking about having. You can see the list there. I'm not going to read down through them. This is not an upcoming schedule. It's just to give you an idea of the things that we think about presenting on. And in fact, some of these I think we've done already. So moving on to our poll. So in each webcast, I ask this question, and we're interested in knowing your usage level of InfraWorks 360. So let me go ahead and launch that poll. And please click your answer to let us know what your usage level of InfraWorks 360 is, ranging from I don't even have it installed to I use it on almost every project, couldn't live without it. Of course, we're hoping that someday that last answer is 100%. This information is really useful to us as we track hopefully an increase in usage level as this webcast series progresses. So it looks like we're pretty evenly distributed actually over the first 4 answers, which is interesting. I think this is the most we've had in the first tier. So great to have some new users of InfraWorks 360 here with us today. Looks like about 80% of you have voted. So those stragglers, if you wouldn't mind clicking your answer, I'll give you about 5 more seconds. And I'm going to go ahead and close that poll. So thanks for giving us your answers on that one. I want to talk a little bit about the InfraWorks 360 community. You'll find the main page at autodesk.com/InfraWorks360 community as you see on your screen. Lots of good stuff here. We've got links to the forum and actually feeds for the forum, Idea Station, and this new thing called InfraTips, which are quick 30-second, 1-minute tips on things that will make you more productive with InfraWorks 360. A lot of times they have short videos with them. So the idea is for you to get in, get out, and get a tip very quickly. And I highly recommend subscribing to that page because we've been posting to that pretty regularly. We've also got the gallery where other InfraWorks 360 users are posting examples of their work. Very interesting to see what your peers are doing. We've got the social hub where we've got live feeds of Facebook and Twitter and various blogs. Any videos that were recently created, including webcasts that we've done previously and recorded, you'll find those on the community site. And then information about upcoming webcasts you'll find as well. One of the newer developments to our community site is this 3-stream feed we have here, the forum, the Idea Station, and the InfraTips. So it's a one-stop shop where you can go to the InfraWorks 360 community page, scroll down, I think, to the second panel, and you'll see this, and it's a whole bunch of stuff that's going on either in the forum, what are people talking about there, what kind of questions are they having, what's been posted to the Idea Station, which is where we ask and get ideas from users like you as to how we can improve InfraWorks 360, and you get to interact with other users and with the product team there. And then, as I mentioned, the InfraTips as well. So it's a great one-stop place to go and see if there's anything interesting you want to check out at a given time. Today we're going to talk about some preview features and some labs features. We just want everyone to be very clear that these are in no way promises that these features are actually going to exist in the software, and that there's no guarantee that they will until you actually see them there. So a little bit of legal speak for you there, but we have to cover that disclaimer, especially with today's webcast, because we are talking about a preview and labs feature together. We want to encourage you to ask lots of questions. We can't open up the phone lines because of the size of our group, but we do have people standing by to answer your questions via the questions or chat window. Please feel free to type in there. There's no such thing as a bad question. So, and the more questions we have, the more interesting the presentation becomes. So with that, I'm going to turn over the controls to Reinaldo, and he's going to take it from here. It's all you, Reinaldo.
Okay, thank you, Eric, for the introduction, and I want to thank all the attendees for the interest in this exciting new product. And I'm going to talk briefly on a little bit on the origin of this collaboration and what is Hydronia, what is the RiverFlow2D model that is the base of the flooding engine for the Project Boulder. So after my short presentation, I will hand out the control to Matthew Anderson, that is going to do a demonstration on the different features of this plugin. Okay, the presentation, as I said, I'm going to do a brief introduction to Hydronia and RiverFlow2D, and then Matt will tell you much more about the InfraWorks and also the plugin with some side demonstrations that we'll show. And you can make any questions during the webinar, and we'll try to answer as much as we can and stay calm. So this project actually started more than a year ago, almost 2 years ago, and we started to discuss Hydronia and Autodesk about the possibility of creating a plugin, a flooding plugin for InfraWorks. And on our side, on Hydronia's side, we're very excited on this because we saw the huge potential that InfraWorks brings to the analysis of infrastructures in a three-dimensional environment. This is something that is unique in the software, especially in the infrastructure software area, and we thought that was a great opportunity to use our developments in the flood analysis software with InfraWorks. And this led to a collaboration agreement that was signed some month ago that led to also the development that you will see today. Now, this has been codenamed Project Boulder, and as you may know, it's available for free trial preview until November 2015. And it's available in Autodesk Labs sites that you can see on the screen. Now, Hydronia is a consulting and software development firm. We are based in the United States, but we have also an office in Spain. And we mainly specialize in hydrologic, and environmental modeling projects. With a lot of the things we do is based on the application of the RiverFlow2D model that I will briefly discuss today, and also the OilFlow2D model that is another suite of models that we develop. And we provide support to government, municipal, private firms in general that are dedicated to assess infrastructure projects, river assessments, flooding, environmental impacts, and a number of projects related that are take advantage of the results of the flood simulations that the RiverFlow2D model can generate. Now, the RiverFlow2D model is a two-dimensional river and estuary hydrodynamics model, but it has a number of components, including sediment transport, pollutant transport, mud and debris flows, and oil spills, overland oil spills. The main characteristics of RiverFlow2D is that it's based on a flexible mesh, what we call flexible mesh, that is formed with triangles, and the triangles can get any size. It can be refined around any geometry or any topography that you may have to ensure that you capture the important features in your terrain. So this is very important because it gives you the flexibility to adapt the mesh to the actual terrain and get much more accuracy in your flooding predictions. Now the model deals with subcritical and supercritical flow. For those of you not familiar with these terms, it just means that the model can handle very fast flows as they occur in very steep areas. So it's not only limited to slow water flows, but it deals with any hydraulic situation that may appear in urban areas or any riverine situation. It can account for hydraulic structures. I will talk a little bit about this in a slide, another slide. It also does distributed rainfall and infiltration, so it works like a combined hydrologic and hydraulic model. And another very important feature is that the model takes advantage of parallel computation, both on multiple core processors and also on graphic processing units. And the importance that this has for practical projects is that the model, using the GPU version, can run 100 times faster than models that do not take advantage of multiple cores or multiple processors. So for large projects, this just means that you can get results in a few minutes or a few seconds instead of hours or days, as is the norm in other type of two-dimensional models. The model also works in English and metric units, so is able to be adapted to different norms and regulations of countries that it's using. The mesh generation in the full version and also in the InfraWorks version that Matt is going to show you today is fully automated. So both in InfraWorks, InfraWorks don't even need to tell you what it does in the background, but it generates a mesh automatically to the terrain. And in the full version, you can have also tools to generate the mesh, and the mesh can be adapted to any geometry, the main river, the floodplain, even flow around obstacles and so forth. So it's very convenient to adapt to irregular environments as often occur in actual infrastructure assessments. You have also a number of graphic output options: velocity fields, water surface elevations, depth, shear stress for number, even hazard assessments you can do by combining the velocity and depth distributions to have a sense of what's the impact of a certain flooding will be on the floodplain, for example. You have 3D capabilities to visualize it that, as you will see in the InfraWorks, this has been superseded with all the tools that you have available in the InfraWorks environment. In the full version, you can also export to Google Earth and view the animations there, so it's very convenient way to disseminate the results, so share results with your clients or the communities that are interested in see what's the impact of certain events would have on their communities. So the model is able to cover a wide range of flows, from the very detailed as the one we are seeing here, where you can actually define the flow around houses and see what certain flooding would cause on them, to large areas as a watershed where you don't need so much detail, and you can use the flexible mesh to cover both the watershed and also the floodplain and the affected area. Now, the main advantages, mainly with respect to other models, is that the RiverFlow2D is a combined hydrologic and hydraulic model. So you can solve both the generation of the flooding to get the discharge, and in the same simulation route that discharge along the river reach you are analyzing. It has a very robust dry-wet algorithm that doesn't require any tweaking, so it's very stable, and that's one of the things that InfraWorks takes advantage of, that you don't need to start, as sometimes other models, that you need to start adjusting parameters here and there to make it work or to make it run faster. RiverFlow2D is such a model that just runs. And it runs stable and accurately every time. Now, it's as I said, it's also very fast with the use of GPU-based version. It covers all hydraulic regimes, and it has been tested in a number of situations, hundreds of projects done worldwide, where it has been checked and compared with actual measurements, and that has demonstrated the accuracy of the model to replicate actual events. The model, as I said, can be extended through the modules for sediment transport, pollutant transport, and so forth, and it's integrated with GUIs, including the one you will see today with the InfraWorks system. Hydronia also offers comprehensive technical support and online training, and we continuously extend and optimize the model all the time. One of the things we have on Hydronia is that we have a very strong collaboration with other institutions, and one of them is the main collaboration we have. We have a strong agreement with the University of Zaragoza, where the University of Zaragoza has probably the most respected computational hydraulics group in any university internationally. And we've been working with them since 2012, and we have, through this agreement, developed many of the features that are embedded now in the RiverFlow2D model that is commercially available today. So this is not a work of a single person. This is a group working together to put the best of each part in the development of the best model that we believe is available. Now, the hydraulic components that are available briefly are the culverts. So you can use culverts of different types, circulars, cross-section, box-type culverts. And the actual culvert calculations, it's taking place inside the two-dimensional mesh to compute the discharge inside this culvert, depending on the depth upstream and downstream. We also include weirs that are useful for urban features like levees and sound walls, different walls that may appear in your urban environment. The weirs can have variable elevations. We can have internal rating table sources and sinks for intakes and so forth. Bridge bridges in different forms. We can actually model the bridge in 2D, and the program will take care of the geometry of the bridge and the energy loss that occurs when the bridge floods and overtops, for example. The model also handles gates, and you can operate the gate with a time variable operation law. And as I said, also does hydrologic analysis of rainfall, evaporation, and infiltration. We recently added the wind component, so if you have, especially in wide area estuaries, you can also model wind stress on the surface that may drive the flow in some situations. So that's what I wanted to show you about the RiverFlow2D model. That is the actual engine running in the InfraWorks system that Matt is now going to show you. So with that, I will pass on the control to him.
I've already done that, Reinaldo. We did have one question come in while we're making the switch here. The question was, does the terrain model handle overhangs?
I'm sorry?
We had a question come in while you were speaking. The question was, does the terrain model handle overhangs?
What's the? I'm not sure I understand what the person wants to as overhang.
So I think what I'm picturing here is, let's say you've got a river channel where the embankment is kind of scooped out and comes back around again and actually hangs out over the water. And if that if that's not accurate, Kelly, go ahead and type in some clarification if you need to.
You mean that the water can come up over? I mean, you could like you have two levels of flow.
Yeah, Kelly says correct. So I guess as you're defining the terrain model for your analysis model, can you include that kind of overhang scenario?
Well, in a certain way, yes, but you need to be aware of the limitations. You could use, for example, culverts to have this. The culvert can be on the top, so you can have a culvert changing flow from one bank to the other bank, let's say, of the river, and that culvert goes over the river itself. And the culvert can be a very big culvert that can be work like as a channel. So in a way, you have the tool to model that type of situation, but it will be represented as a box culvert maybe that is conveying the flow from one side to the other side.
Okay. I guess it's all you now, Matt.
All right, thanks. I did see a question come in about which version of InfraWorks does this work with. And right now, the Project Boulder is a labs project. So if you go to labs.autodesk.com, you can go to that and download the Project Boulder installer. There's a link to the Hydronia page to download the RiverFlow2D model. If you install both of those, they install on the InfraWorks 360 module. So right now it does not work on the LT, but it will work in trial mode. So if you have the InfraWorks 360 and you want to trial it, it'll work on that platform. All right. So once you have InfraWorks and InfraWorks 360, Project Boulder, and RiverFlow2D modeled, we have placed pretty much the analysis for the flood simulation really on all of the different analysis options, whether it's if you have the drainage, the bridge, the road, or just the straight InfraWorks 360 module. Flood simulation is available really on all of the analysis tab. And Project Boulder, our partnership with Hydronia and Reinaldo is provides early access to create a simulation area, to create a simplified mesh really without a lot of mesh knowledge, establish some Manning values, provide some basic hydrology or hydraulic information, and perform the analysis and get those results, and do it within the InfraWorks environment, which is really a three-dimensional vision. Reinaldo did a really good job of talking about what RiverFlow2D has the ability to do. We're not 100% there yet with Project Boulder, so this is where feedback from you, the users, is critical to determine what needs to come next, what information, what tools do you need to see, in InfraWorks to make this useful to you. That feedback is critical to determine whether this tool graduates and becomes an actual offering. So let me kind of just walk you through a little of that. And the first thing is we want to define a boundary for this study area. And I always want to hit my bookmarks, and I always hit that. So my bookmarks, let's go to the quick start bookmark. And I've got a model here, I think it's in Wyoming, and I'll just kind of very quickly digitize the area that I want to begin a study for. And it'll give you an idea of what that is, what that area is. And honestly, I think this flows more east. So I'll go ahead and define where I expect water to enter this study area. Right now, Project Boulder can only handle, we only do one inflow and one outflow, where I know RiverFlow2D can handle multiple elements. So once double-clicking on both of those elements, we get the flood simulation dialog. And if at any time you're not happy with either the placement of the inflows and outflows, simply clicking and editing these values, or honestly, if I double click on that, I jump out. If we also select the outer boundary and make a change, that is possible as well. So in the flood simulation, we have the ability on the on the inflow right now to add a static flow, a steady flow into the model. So I can go ahead and enter 2000 CFS. The outflow condition, I can leave it as uniform or free flow, and we can give that uniform either an average slope condition or define that slope condition as we see fit. And one of the things in the first release of Project Boulder, we had a set size for the triangles. We now have a slider available that allows you to tighten a mesh up. This is a lot of triangles. We'll leave that at roughly 50 here, 50-foot size. And geospatially, we know at some point we need to provide coverages and manning and geospatially, but right now we have a uniform mannings in, and we can assign both the simulation time as well as that time interval. And project now doesn't works or that the analysis is pretty quick. Based on these parameters, within 30 seconds we'll get a very quick analysis back. And part of that is because of the static inflow that I'm using here. And that'll give us just a very quick overview. And I'll switch models in a little bit and show you the dynamic overview and some of the animations in a second. But one of the things that we did do is we are adding hydrographs where allow us to actually go and grab a time series text file and import that and run that. That obviously takes a little bit longer to run, so I'm not going to show it to you here. I'll show you the results in a little bit because it does take quite a bit of time to actually compute. But that is something that I'll show here in a second. But InfraWorks provides very different context. In the market today, most animations are pushed out to a wave file, and you're left with not being able to identify that animation. But we thought it would be very interesting to incorporate the simulation results directly in the model. So here we are looking at the animation of that model in 3D, and I can actually continue to pan and zoom around during that animation to see how a model interacts. So I can see if we were needing to do some kind of a small bridge through here, I can begin to see what the impact of that analysis is doing while I draw that bridge. And we can also go and, if we hit stop, select depth again, regenerate that animation, we'll get a blue depth theme to that water surface. It's still in 3D, so these are truly, that is the water surface elevation. We're just theming that based on the depth. And we can also look at the velocity results that RiverFlow2D provides. And provide the velocity fields to a point where we can even create a snapshot that we can stop this and prepare that snapshot. So this is right now in InfraWorks 360 only. It doesn't go to the web viewer correctly with the theme. But we can leave this as a three-dimensional object in InfraWorks, so you can begin to inform other decisions, whether you're laying out a road, whether you're laying out a bridge, whether you're looking at specifically any grading objects. And right now, obviously, this is just a model builder terrain model that has a wonderful visualization because of the elevation that we have. But any of the grading elements, whether that is a road, a bridge, whether you've grabbed the coverage area, manipulated that, gone to Civil 3D, created a terrain surface, imported that into InfraWorks, you have that ability to run that model against those results. So it works, with all of the terrain, the finished ground terrain that you have in the model, and that provides, a lot of context, not only with the model, but with how water flows over the model. So let me go ahead and I'm going to go quickly.
Couple of questions.
Eric, any quick questions?
Yeah, a couple actually. One is, does this, can you run Project Boulder on the sandbox? And I realize that might be a little tough to answer. Matt, did you hear the question?
Yeah, I did. Sorry, I had to hit the wrong button. No, it does not currently run on the sandbox.
Okay, and the other question was, can you export this data, such as the limits of flooding, to Civil 3D?
Not at this time.
Okay. That's all we have for now that is unanswered, so
All right.
please continue.
All right, give me 1 second. It's going to take about a minute or two to load this other model here. And I'll go back to showing my screen. So we should see a different model now.
Yep.
All right. So this is, I think this is one of the standard HEC-RAS models in California. So in this model, I've selected the hydrograph type, and I've already run the results. It took just about an hour to get this model done. I've got my flow. I've been able to select this. This isn't on the current download, but this will be up there shortly. So we've got this hydrograph where we see, in this case, from time 0 to time 1.5, and I've run the model with a 2-hour window. So we can begin to see the power that RiverFlow2D can provide. The two-dimensional, time-varying hydrograph, and its visualization and animation in the model. So give it a second here as we so that hydrograph is running this water surface elevation with velocity arrows. We show the flow flooding and then beginning to drain the model in that 2-hour time slot. So this is the beginning to take a look at the time varying aspect of 2D flow. And giving that ability to really begin to, I don't want to say challenge RiverFlow2D, because I'm not sure we're there yet, but begin utilize RiverFlow2D for a true two-dimensional model.
A couple more questions,
So again,
Matt, if you want to field these.
Sure. I'll let this just animate and let me take a look at those questions just on my other monitor. Sure.
All right. Question was, are there any reporting options?
Currently, Project Boulder does not, but RiverFlow2D does have reporting ability.
Okay. And a related question, can we create a data chart for the different colors for velocities and depth?
Right now, no, they are hard-coded, but if we want to expose, velocities, elevations, depths, give you that ability to theme those as an object, I think we can add that to the list of items. So.
Right. And another question about capturing this. Can we use screencast, for example? I'm rephrasing the question, but can we use screencast to capture this animation and maybe embed it somewhere or something of that nature?
Absolutely. Yeah. So InfraWorks has screencast, and it will record this animation as it plays. Obviously, you may want to hide some of the dialog boxes, over on a second monitor or something. But yeah, it will record this, so you can have a playback, via screencast.
Could you capture a storyboard while this animation is running and have it be captured in the storyboard?
That's a good question. I haven't tried storyboard yet, and that wasn't on our radar. So I may have to check that out. I'm not sure.
Great questions, by the way, and definitely a lot around visualization. So that's interesting. Well, a comment that it would be nice to fly the channel as it floods. Our good friend David Lawrence made that suggestion.
Yep, sorry. Pretty sure we can. I can definitely look into that here after the call.
Another question, can you explain the difference between free flow and uniform flow? Is there any recommendation about how to choose it?
Reinaldo, would you like to tackle that question?
Sure. Yeah, the free flow is actually a condition where the discharge or the volume of water that it approaches the outflow boundary is just let go out of the boundary. It's called free, although it's not, totally free, but it's a less restrictive boundary condition where just the water, it's let go on the boundary. There is no other relationship imposed there or other than that in general from cell to cell. In the uniform flow is different in the sense that the model generates a rating table on the boundary based on the slope that the user would provide, and that rating table, which is a relationship between the water stage and the discharge, is used to determine that relationship that will let the flow go out. So when you have water getting to the boundary, the model will use the relationship between stage and discharge for the whole cross-section based on the uniform flow calculations that was done, and we'll use that relationship to impose the combinations of water depth and discharge for that condition. So they're two different, they're very different in that sense. But they have their way. They both are commonly used in practical applications. Sometimes you have, especially when you have multiple outflows, boundaries, you can use free flow. Sometimes it's more convenient because you don't know anything about that boundary. For example, you don't know the slope. You are not very sure about the cross-section there, so you can use as an initial approximation the free flow there. If you have more data, then you have slope, you have more other information, then you can use the uniform flow condition.
Thanks, Reinaldo. Let's see. Are there any other questions?
I think we're pretty caught up on questions. Oh, there was a new one that just came in. Is anything being developed to model flooding due to overflow from a storm sewer network?
I can't really talk about future capacity, but that is something that is possible. You know, the RiverFlow2D model does that. I mean, and there are, we do have the drainage design model, so that's something we can look at. Yes.
Yeah, and almost the same question again from Dilip Kumar. So, some folks interested in that capability as well.
Okay. Yeah, I've received, and I'll put in the plug for the Autodesk Labs user forum. There's also an email alias, and I know I've gotten a number of emails with regards to, I guess, what would be a you'd call it a coupled model, where you have the 2D surface flow with the one-dimensional pipe flow, and you would have inflow outflow coming through that, which so that is on the list of things to look at for Project Boulder, next steps kind of thing. So that's what Labs is about, is, you know, get some early preview technology, get customers like yourself to look at this, you know, see if you can identify problems that you have that you'd like, you know, to see the priority of the development of this tool, how that works. So, you know, Labs, the user forum, as well as email alias, great places to get for us as a product, myself as a product manager, identifying what you as customers need to do helps us prioritize you know, steps. So for example, one of the things that over the past couple of releases of Project Boulder, we've added the uniform flow feature, we've added the hydrograph feature. You know, there are things, obviously, we've got culverts in our model that we can add. We have bridges. You know, there are a number of different things. Your feedback, questions here, things like that, kind of drive how we drive the product. So
we had a kind of a stream of additional questions that came in regarding yet more functionality, wetland development, simulating a tanker fuel spill, tidal, rising sea level. So these are all things that I guess we can consider including in our analyses.
Yep, yeah. I think there is a. I wish I remembered the gentleman's name, but there is a blog post that one of the Autodesk resellers put together, utilizing RiverFlow2D to simulate flooding of Manhattan for Hurricane Sandy. I wish I could remember that, but I think so. It's one of those things that we, you know, it can be done, and it's a matter of putting it together. So.
Yep, and some more comments about the importance of reporting and visualization. So those are well noted, David.
Yep. Can we have an example about infiltration? Right now, Project Boulder doesn't do infiltration. One of the RiverFlow2D, and I'll let Reinaldo here chime in a second, but you know, distributed. You know, we have materials in InfraWorks. You know, those can then have probably, I think it's a curve number. You know, and when you have a distributed rainfall, you know, working with the RiverFlow2D model, but I'll let Reinaldo go into a little bit more detail about that, so that we can. I know his engine is capable of more things than what Project Boulder has exposed.
Yeah, let me briefly summarize some of the things of the RiverFlow2D. As Eric mentioned initially, we are not sure of where this tool is going to go. Because we are on the trial. You know, the purpose of the trial is to get feedback from potential users and see. Autodesk and Hydronia will evaluate all this after this, and then decide, you know, whether it's going to go in one direction or other direction. But it's important that you understand that this is a trial version. It has a big potential, and already it can perform simulations very quickly and visualize. But bear in mind that there are a large number of features that could eventually be implemented if this goes in full production. It's not sure yet, but that's one of the things it needs to be evaluated. One of these tools is the infiltration and distributed rainfall. Presently, RiverFlow2D provides that capability, so is there a potential to implement those also in InfraWorks? And it does infiltration using 3 different methods, green ant, Hurton, or curve number, and it deals with the infiltration as a loss. So it calculates the volume of water that is leaving due to infiltration, and it can account not only for rainfall but also for infiltration due to the depth of pounding that you have in the different areas. That applies also to other of the questions that I've seen here, for example, related to title. Title is already available here because you can represent essentially a time-varied condition due to tide, so that's also available. But there is a number of features that if the product gets in full production, then it could be implemented eventually because the model already provides for all that functionality.
Yeah, and I see a couple other questions. One about roads and design roads and design bridges. You know, right now the road, because it is the finished ground terrain, is part of the mesh that we send to RiverFlow2D. You know, the opening where the bridge is, you know, where it goes down to existing ground, that is part of the mesh that goes to RiverFlow2D. The bridge itself, the bridge piers, we don't have that hooked up in Project Boulder at this point, even though we know that RiverFlow2D can utilize that, and that goes for the preview feature with component roads as well. So.
Well, if anything, we've got lots of ideas for future development from our viewers today. So lots of great ideas from everyone.
Yep. So Eric, I'll turn it back over to you.
Okay. So Matt, I think you wanted to maybe take a moment and talk about labs because we had this slide in here. So do you want to do that?
Yeah. Obviously, where you go and grab the download here, there is a forum on Labs, and you know that's probably a great place for a lot of these questions. You know, we'll go ahead and put answers in there, you know, to a lot of those things, but that helps us identify and get that feedback from users to help us begin to prioritize. You know, we've got that slide there, so labs.autodesk.com. In that list there is the Project Boulder. That's both where you download Project Boulder as well as the RiverFlow2D model for InfraWorks. You know, there's links there for that, but you know, these page views, these comments, these the feedback that we get, you know, really helps determine the future of this, how it graduates, and what type of a product it may become. So it's important, you know, for participation. You know, so share your ideas there, and you know, that's kind of how the product team works. You know, we get these ideas, we share with you something, and from those ideas, from what we shared, you know, we make decisions as to what the next direction is. So.
Matt, for the sake of those on the call who I hope is everyone who wants to go out and try this out, I know the process is a few more steps than we're used to with the labs projects. Can you just roughly talk through the fact that you have to download and install multiple items with this project?
Yeah, so if you've never seen not InfraWorks, you know, InfraWorks 360 is required. At the lab site, there is a download for Project Boulder, and then, you know, because Reinaldo is our partner, there is a you know, another item there, which is the RiverFlow2D model, and there are links. It's not Autodesk's product; it's Reinaldo. That's why he's here. It's a partnership between Autodesk and Hydronia. So there is a link to his website where you can fill some information out and you know, and get the RiverFlow2D model for InfraWorks. Both of those are required, you know, on top of InfraWorks 360. So there's only the second step because it is a partnership. So.
Great, thanks for explaining that. Well, I think that's about all the content we have for today. I want to remind everyone that this is a webcast series, and we do this twice a month. So we did have a last-minute switch on the webcast coming up in 2 weeks. So I don't yet know the topic for that, but that will be coming out soon. So please join us again for the second webcast this month, and then for all of the webcasts to come as well. Great job, Matt and Reinaldo. Thank you so much for all the information you shared. Hopefully we've recruited a whole bunch of labs participants to go out and download and install this and give us tons of feedback so that we know the direction we need to go with it. Thanks again to everyone who attended, and have a great day.